Hello, and welcome to another micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets to common math and physics problems from homeworks and exams. Today's problem is an undergraduate college topic in linear algebra involving the solution of eigenvalues and eigenvectors. It turns out that this problem the solution to this problem we will use in upcoming micro tutoring sessions. So it's going to be useful to have this solution done, and then we'll go on to some other micro tutoring sessions which will use this result. So let's get right down to it. Suppose you have on your exam problem, you're asked to solve this eigenvector, eigenvalue problem where the matrix A, and I use this double underscore to denote a matrix, and a single underscore to denote a vector. So the problem is matrix A times vector V equals scalar V times the vector V. So this is an eigenvalue, eigenvector problem where we'll call it an operator, this operator A, this matrix A, operating on this eigenvector V equals some scalar eigenvalue times the same eigenvector. And in the problem we are given the matrix A. The matrix A is this, 5 minus 3 minus 3, 5 times the eigenvector V equals an eigenvalue V times the eigenvector V. So let's go ahead and move forward. What does this equation say to us? Well, we can actually rewrite this by subtracting the right-hand side from both sides. So that will give us matrix A minus the identity matrix times the scalar eigenvalue times eigenvector V equals the zero vector. So all I've done is subtracted the right hand side from both the right hand and the left hand sides of this equation and written this down here. So now we know from linear algebra the solution of this has the determinant of this quantity equal to 0. So let's write that down. So this means, so we're going to go up to here, that the determinant of matrix A minus the identity matrix times eigenvalue V has to be 0. This is a result that we know from linear algebra. This is called the characteristic equation. So let's go ahead and solve for this. So this is using bars for denoting the determinant. So 5 minus V minus 3 minus 3, 5 minus V. This determinant must equal 0. All I've done is written out the characteristic equation. So this times this minus this times this. So 5 minus V squared minus 9. So this is, let's see, 25 minus 10V plus V squared minus 9. Let's just keep going with this. So this is V squared minus 10V. And we have 25 minus 9 is 18, I believe. 16 plus 16 is 0. Okay, so this is, we're just writing out the characteristic equation. So let's try to factorize this. So I believe this is going to look like let's see, I think it's, maybe let's try this. Let's check v squared, and we have 16 minus 2v minus 8 is 10. Okay, that's right. So this is, again, just the characteristic equation, which is this. So then this tells us that the roots of the characteristic equation are the eigenvalues. Let's see, so that means the eigenvalues are 2 and 8. Okay, so we have part of the problem so far. We have the eigenvalues right now. So now let's solve for the eigenvector that corresponds to eigenvalue 2, and let's find the eigenvector that corresponds to eigenvalue 8. So let's move on over here. So I'm going to write this as A. So let's look at eigenvalue 2 right now. So we're going to solve for the eigenvector that corresponds to eigenvalue 2. So A times the eigenvector with eigenvalue 2. So I've just put a little superscript 2 to represent that this is the eigenvector that corresponds to eigenvalue 2. So A times the 2 eigenvector equals the eigenvalue, which is 2, times the eigenvector that corresponds to eigenvalue 2. Okay, so let's just write this down and put everything on the, let's subtract this from both sides of the equation. Okay, so this is going to be A minus I times 2 times the eigenvector 2 is 0. So this is 0 vector. Okay, so what does this tell us? So this is 5 minus 2 minus 3 minus 3, 5 minus 2, so the first component, and then the second component, this is 0, 0. Okay, so now keep in mind what we're doing. All we're doing is solving for the eigenvector that corresponds to eigenvalue 2. We've already solved for our eigenvalues. Now we need to obtain the corresponding eigenvectors. So this is the eigenvector problem for eigenvalue 2. A times, it's the eigenvector for 2, eigenvalue 2, equals the eigenvalue, which is 2, times that eigenvector. Okay? So we've just subtracted this from both sides of this equation, written this out here, and then we can, let's get some more space. Okay, so now this, let's just write out, so this is, remember, matrix equations are just shorthand for equations, for a system of equations. So let's just explicitly write out the system of equations that this matrix equation is shorthand for. So this is 5 minus 2 is 3, so I'm just going to go up to here. Whoops, let's get another marker. So we're going up to here. 5 minus 2 is 3. Minus 3. 3 V1 eigenvector 2 minus 3 for V, this is 2, sorry. The second component is 0, and then we have minus 3 times the first component plus 3 times the second component. Okay, so all we've done is explicitly write out the system of equations represented by this matrix equation. All right, so we look at this. So all this means is that we look at this V1 equals V2. So both components of this eigenvector are the same. So we think, all right, so we can pick any value that we want. It's convenient, and the simplest one I can think of is just to set both of them equal to 1. Okay, so that means V2 equals 1, 1. And then if we want this eigenvector to be orthogonal and normalized, meaning that its magnitude is unity, we just multiply it by the normalization factor, 1 over the square root of 2. So this is an orthogonalized or orthonormal eigenvector corresponding to the eigenvalue 2. Now, we go through the same steps to get the eigenvector corresponding to eigenvalue 8. And it's the same stuff, just wherever you see 2, put in an 8. Nothing fancy. And I'll just save you the labor, and I'll just tell you the result is the eigenvector corresponding to eigenvalue 8 is, again, we have the normalization factor 1 over the square root of 2, and then instead of both components being equal to each other, we're going to get that one is the negative of the other. So that's the simplest one we can come up with, is minus 1 and 1. Okay, so that is our solution for today. We have, these are the eigenvalues. This is the eigenvector corresponding to eigenvalue 2. And this is the eigenvector corresponding to eigenvalue 8. Eigenvalues, the eigenvector corresponding to eigenvalue 2, and the eigenvector corresponding to eigenvalue 8. So that's it for today's micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets to common math and physics homework and exam problems. Prep Plus is your online solution for customized learning in math and physics for high school, college, and returning scholars. I'm Rodney Green, the president of Prep Plus, and I invite you to contact me to schedule a free consultation. Check out the website prepplusinc.com.